Three astronauts climb into a Soyuz spacecraft, strap themselves in, and prepare for an adventure that will last nearly a year. Two of them will return home just 4 months later. But one of them, well, he'll stay up there for almost double that time. And it's not just for fun either. There's a lot riding on his very long stay. Humanity is depending on him and his crewmates to lay the groundwork for our first ever mission to Mars. But before they can do any exploring of their own, they've got to contend with one of the most formidable obstacles that any astronaut faces: leaving Earth. On March 27, 1996, the three astronauts aboard Soyuz TM-23 lift off from Baikonur Cosmodrome. Their mission to the newly operational International Space Station is a big one. Not only are they responsible for delivering important cargo to the station, but they're also responsible for installing new systems like the U.S. Lab Module, which contains important scientific equipment for research and serves as a future attachment point for the International Space Station's robotic arms. But it's not just them bringing new stuff to the ISS. They're also bringing new life, because these are the first occupants of the space station since its recent opening. They're here to turn the ISS from a construction zone into a functional research lab. Amongst them are two veteran cosmonauts, Boris Yeltsin and Pavel Vlasenko, who have flown into space twice each. But there's a third, less experienced crew member, a NASA astronaut, named Scott Kelly. He's one of the lucky few to have been selected for the so-called twin study, which seeks to better understand the effects of space travel on the human body by studying him and his identical twin brother Mark, who remains firmly on the ground. Before takeoff, blood samples from both twins were collected and stored in a biobank, and from there the brothers would essentially be used as a control group of one. Since they're genetically identical, any differences between them after returning to Earth could potentially be linked to Scott's time in space. As the Soyuz hurtles through space, we get a moment to catch our breath and think about all the ways that space can affect the human body. Sure, we know that it can cause your face to swell up a bit thanks to fluid redistribution. That happens when blood and other fluids that are normally distributed throughout your body pool in your head. This can make you look like you have a neck twice as thick as your head, and it might even make it a little harder to breathe. But it's nothing a little time can't fix. Similarly, your spine expands in microgravity. You see, the discs in your spine are like little cushions filled with water. Back on Earth, gravity pulls everything down, making them compress a little bit. But without gravity, they just expand. As a result, the average astronaut grows a couple of centimeters while in space. And don't worry, there's no danger of these astronauts turning into giants while in space. Any extra height they gain is only temporary, and the reason they grow taller is actually one of the ways that the body adapts to space. While some of these adaptations are helpful, others can be downright dangerous. Without the constant pull of gravity, muscles that are used to being worked against gravity, like your calf muscles, can start to atrophy. But the good news is that regular exercise can help keep these muscles strong. So during their stay, the crew of the ISS does 2 hours of exercise every day. Most of that exercise is split between a stationary bike and a special treadmill. But they also have a resistance machine on board that uses air pressure to simulate weights ranging from 6.8 to 271 pounds. These workouts aren't just good for their health, they're also generating valuable data for scientists back on Earth. In fact, the crew of the ISS performs dozens of experiments related to the effects of long-duration spaceflight on the human body. One study, for example, had them take photos of their own legs so that doctors could analyze the muscle definition in their lower limbs. But the real value of the twin study comes from comparing the samples taken from Scott before he left and after he returned. From that, scientists learned that spending nearly a year in space can change the expression of thousands of genes. Now, gene expression doesn't necessarily mean that something is wrong. In fact, many of these changes seem to be beneficial, allowing Scott's body to better repair itself at the cellular level. But the study also found that certain genes related to fighting cancer and infectious diseases became less active in Scott, which may leave future astronauts more vulnerable to illness while in space. That's why it's important to keep studying the effects of spaceflight on the human body, because we may still be years away from launching a crewed mission to Mars, which would take at least 2 years to complete. Astronauts will be spending more time in space than they ever have before, and we want to make sure that we have the tools to keep them healthy for the entire trip. Okay, let's get back to the story. Meanwhile, the Soyuz approaches the ISS and the crew begins preparing for docking. A few hours later, they're gently brought to a stop relative to the space station, and they release the craft's internal pressure so that the docking can proceed. A hatch is opened and the crew makes their way inside, where they're greeted by a pair of fellow space travelers who arrived on a previous flight. Over the next 4 months, the crew of Soyuz TM-23 works hard to assemble the International Space Station. They finish outfitting the U.S. lab module and prepare the station for future occupants. And they work closely with the other crews arriving at the ISS over the next few months to install solar panels, air ducts, and other critical systems. But they're also busy conducting science too. Thanks to the technology that was delivered by their Soyuz, researchers on Earth are able to study plant growth in space for the first time. The Veggie 1 experiment aims to determine if space-grown veggies can be eaten safely, and if they can be grown efficiently enough to support long-duration space missions. Other experiments investigate the properties of combustion in space and test the effects of microgravity on mouse cells. But the crew's hard work pays off in more ways than one. For example, they're able to test a new type of inflatable exercise equipment designed to save space on future spacecraft. And they collect detailed measurements of the cardiovascular system with the help of an advanced medical kit. After 4 months in space, it's finally time for the crew of Soyuz TM-23 to return to Earth. But only 2 of them will make the journey home right now. That's because Scott Kelly has decided to stick around for another 6 months. So while Boris Yeltsin and Pavel Vlasenko prepare to leave the ISS, Scott gets ready to settle in for an even longer stay. His replacement, American astronaut Bill Shepard, arrives on a later flight and becomes the first commander of the International Space Station. But when Scott heads back to Earth 5 months later, he finds that he's not quite the same person he was before he left. The isolation and confinement of living in a tiny spacecraft for months on end takes a toll on his mental health, and while he feels great physically, he struggles to adjust back to life on Earth. But thankfully, he's not alone. As part of the twin study, Scott is reunited with his brother Mark so that the two can undergo a battery of tests and checkups. At first, the results are mostly good, and as expected, the extra care taken to monitor Scott's health means that he's able to set a new record for the longest single spaceflight by an American. But as time goes on, it becomes clear that there are some unexpected consequences to spending so much time in space. Scott's eyesight has deteriorated significantly, which could pose a serious risk to any future astronauts who require good vision to perform their jobs. But despite these challenges, Scott is able to make it back to space again. In fact, he'd go on to fly a total of 4 missions and spend a total of 520 days in space. So, while this wasn't the first long-duration spaceflight, it was definitely a pivotal moment in our exploration of space. If we want to send humans to Mars, we need to understand the risks involved, and we need to make sure that we are prepared to deal with them. Studying the effects of a long-duration spaceflight on the human body is just one piece of that puzzle. But thanks to the research conducted on the ISS and by the brave astronauts who volunteered for it, we're learning more about the effects of space on the human body than ever before. We may be farther from Mars than ever before, but thanks to research like this, we're also better prepared than ever to get there.